Hello friends, this is Dr. Sudhan Sharma from School of Computer Information Sciences, Indira Gandhi National Open University, and this session is about the matrices and introduction. Now, in the earlier sessions, we had already discussed about the introduction to the determinants, and we had also learned about the application of the determinants, wherein we learned about how to calculate the area of the triangle, and we learned how to apply the Cramer's rule. We also learned about the properties of the determinants, but matrices and determinants goes hand in hand. They are generally used interchangeably because determinants represents the value of the matrix. Generally, matrices are representing the vector component, whereas the determinants are representing the scalar component. But generally, we are using the words interchangeably. But so far as the vector addressing is concerned, we need to deal with the matrices, and if we want to calculate the value of a matrix, then we need to work with the determinants. Now, in this session, we are going to discuss about several things. The session objectives are about to understand and define the matrices. Apart from this, we are going to learn about the different types of matrices and perform equality, addition, multiplication operations on the matrices. Now, firstly, we understand what a matrix is. In fact, matrix is a rectangular array of the number, and wherein we are going to say we can represent the dimensions. Say, if you are from the background of the programming, we are having multi-dimensional array. So, the rows and columns are actually representing the dimensions. Likewise, over here, if we want to know that which food has got vitamin A, vitamin B, and vitamin C, to what extent, then the two variables are food type and the vitamins. Apart from this, the vitamins values are also categorized as vitamin A, vitamin B, vitamin C, and food values, say there is a type 1 food, type 2 food, and type 3 food. Now, this is a rectangular arrangement wherein we are easily able to see that 0.4 is the value for vitamin A in food 1, 0.5 is the value of vitamin B in food 1, and 0.1 is the value of vitamin C in food 1. Now, we can represent this value into matrix form by this. Likewise, over here, if I say this, now this enclosure is nothing but a matrix, wherein this value is represented A11. That 11 is first row and first column. Now, this is second row and first column. So, this value will be equal to A21. This value will be third row and first column. So, this value will be A31. Now, similarly, we will be having A12. Similarly, we will be having A13. That is first row and second column, first row and third column. So, this is how the values are distributed when we are going to deal with the rectangular component of a matrix. I hope you are able to understand what do we mean by a matrix as a rectangular array of elements. Now, by the definition, we mean to say that a matrix is nothing but an M cross N arrangement of the elements, where an M cross N implies that it is a rectangular array of M and N real or complex numbers, which are arranged into M horizontal rows and N vertical columns. Likewise, over here, this matrix is of order 3 cross 3 because there are 3 rows and 3 columns. So, this means M is equal to 3 and N is also equal to 3. Now, generally many a times we can have only a row matrix or a column matrix. Likewise, over here, this represents a row matrix and this represents a column matrix. Now, where the elements are represented by the value of Aij, where Aij represents the ijth element of a matrix. I literally said that that over here, if you want to understand what do we mean by Aij, then again let me cite, this is the first row and first column. So, this value will be ij value will be equal to 1 1. So, this is first row and first column. If I go for this, this will be equal to second row and first column. This column is third row and first column. I hope you are able to understand what do I mean by ijth element. So, the diagonal elements are A22 and A33. That is third row, third column, second row, second column, second row, second column, third row, third column. Now, uh, the general representation of the matrices are concerned, they can be represented in these of the three following formats. So, and the combination, the maximum value of I and the maximum value of j represents m and n, and m cross n represents the order of a matrix. So, if I want to say that this matrix is of order 2 cross 2, and this matrix is of order 2 cross 3, because there are 2 rows and 3 columns. So, this is of order 2 cross 3. Now we are having different types of matrix. Likewise, over there is only single row. So, this is a row matrix. There is a column only. So, this is a column matrix. All elements of this matrix are 0. So, this is a 0 matrix. And in this case, we are only having the diagonal elements. So, this is a diagonal matrix. This is a rectangular matrix because number of rows is not equal to number of columns. The number of columns are 3 and number of rows are 2. So, this matrix of this is of order 2 cross 3, and because no rows is not equal to columns, so that's why it is a rectangular matrix. Over here, because the number of rows is equal to number of columns, 3 into 3. So, that's why this is a square matrix. We are having 3 rows and 3 columns. Similarly, we are having a unit matrix wherein the diagonal elements are only 1. So, such matrix is known as a unit matrix. Apart from this scalar matrix, you should not be confused of the scalar matrix and the unit matrix, because if we take 2 as outside over here common, then the values will be 1 over here across the diagonal. So, 2 into unit matrix, identity matrix, then this is a scalar matrix because we are representing a scalar value outside, and then we are having a unit matrix. So, when we will be discussing about the vectors, we will be using the notation 2 into I, where I is the unit vector, I is the unit vector, and 2 is the scalar value. So, this is what is over here. We are writing 2I, 2 is the unit vector, and 2 is the scalar value, and I is the unit vector. So, need not to worry, we will be discussing about these details when we will be discussing about vectors and all those things. Apart from this, we are having one more type of matrix, that is the upper triangular matrix and lower triangular matrix. And in the when we were discussing about determinants, we learned that when the values are say A1, B1, C1, 0, A2, say B2, C2, 0, 0, C3, the value of the determinant, the value of rather determinant will be the multiple of the diagonal elements A1, B2, C3. This was one of the property which we had learned in the last session. So, we can apply that property when we are going to solve this upper and lower triangular matrix. So, in this case, the solution should be 1 into 4 into 6, that means 6 4 the 24. This should be the value of this determinant when we are going to solve this as for the determinant. And for this, when we are applying this property A1, B2, C3, 5 into 1 into 7, 5 into 1 into 7, 7 5 the 35. So, 35 should be the value of this. So, I hope you are able to understand that we should not feel that whatever we had learned is not of any utility. We are now over here applying the properties of the determinant in solving the upper and triangular matrix when we are going to apply it for the determinant values. Now, when the two matrices are said to be equal. So, in order to understand about the equality of the matrices, let Aij be a matrix of order m cross n, and B is equal to Bij is a matrix of order r cross s. Now, the two matrices are said to be equal if the value of m is equal to r. So, this value should be equal to r, that is number of rows of both the matrices should be same, n should be equal to s, n should be equal to s, that is number of columns of both the matrices should be same. Apart from this, Aij and Bij, Aij is should be equal to Bij, that means the values, if A is equal to say I mean to say A1, B1, C1, A2, B2, C2, A3, B3, C3, and say B is equal to L1, M1, N1, L2, M2, N2, L3, M3, N3. Then both matrices are of order 3 cross 3. Both of order 3 cross 3. That is M is same and N is same. and they will be equal when A1 is equal to L1, A2 is equal to L2, A3 is equal to L3. Similarly, for B1 is equal to M1, B2 is equal to M2, B3 is equal to M3, C1 is equal to N1, C2 is equal to N2, C3 is equal to N3. Now, so that means then only we can write the value A is equal to B, and matrix A is said to be equal to matrix B. So, now in order to apply the understanding of the equality of the matrix, let's solve one numerical. Given, say, let A and B be two matrices given by A as x plus y, 3y minus 7. Now, what type of matrix it is? It is a column matrix, because we are only having the values in the column. Again, B matrix is also of type column matrix. So, both are of order 2 cross 1. Two rows are there and single column is there. So, the order is 2 cross 1. So, since first requirement is order of matrix A is 2 cross 1, order of matrix B is also 2 cross 1. Now, the element should be same. That means Aij should be equal to Bij, should be equal to Bij. Okay. So, when we apply this third requirement, then we need to point-wise equate the values. That means firstly we should place x plus 2 should be equal to 4 minus y. This x plus 2 should be equal to 4 minus y. Similarly, 3y minus 7 should be equal to x minus 3. 3y minus 7 should be equal to x minus 3. So, these are the equations. By solving these equations, firstly we can interchange the values. So, this solving x plus y, you will get x plus y is equal to 4 minus 2, that is equal to 2. So, x plus y equal to 2 is one of the equations. Thereafter, we will be having another equation, that is 3y minus 7 is equal to x minus 3. So, 3y minus x is equal to minus 3 plus 7, that is you can say that 3y minus x is equal to 4, or minus 3y plus x is equal to minus 4. Now, solving these two equations, we will get the values x is equal to 1 by 2 and y is equal to 3 by 2. How we are going to solve these equations? Just wait for a moment. Say, now we are having x plus y is equal to 2 and x minus 3y is equal to minus 4. By equation number 1, solving equation number 1, x is equal to 2 minus y. Using 3 in 2, we get 2 minus y minus 3y is equal to minus 4. So, is equal to minus 4. So, you will get 2 minus y minus 3y is equal to minus 4, that is 2 minus 4y is equal to minus 4. That means 2 plus 4 is equal to 4y, that means 6 is equal to 4y, that is y is equal to 6 by 4, that is equal to 3 by 2. So, y is equal to 3 by 2. So, using this value, using y is equal to 3 by 2 in equation number 3, use y is equal to 3 by 2 in equation number 3. So, equation number 3 is x is equal to 2 minus y, that is 2 minus 3 by 2, that is equal to 4 minus 3 by 2, that is 1 by 2. So, this is 1 by 2. So, that means x is equal to 1 by 2, y is equal to 1 by 2. Now, in order to get the result that what is the value of a and b, then we need to substitute the values of x and y in the expression which is given to us, that is x is equal to a is equal to x plus 2y, and so we will get the values a is equal to x plus 2, 3y minus 7. So, by substituting the value we will get 1 by 2 plus 2 and 3 into 3 by 2 minus 7, which is this, and solving the value you will get 5 by 2 minus 5 by 2. Similarly, by substituting the values of x and y in this expression, you will get the value b is equal to 5 by 2 minus 5 by 2. Now you can say that a is equal to b because both values are same. I hope you understood that how to apply the understanding of equality of matrices to solve the numericals. Now, thereafter, another important concept is the transpose of a matrix. The definition of the transpose of a matrix says that we can change rows into the columns. That means, let Aij Mn be a matrix. That is, Aij are the elements and Mn are the orders of the matrix. Then the transpose A is denoted by A dash, and transpose of A is the matrix A ji, not Aij, it will be Aji, and the order will be n cross m, not m cross n. That means the rows are changed into column and columns are changed into row. Likewise over here, minus 3, 2, 5, 0, 7, 8. That means there are 2 rows and 3 columns, so order is 2 cross 3. 2 cross 3. If we change row into column, then it will be minus 3, 2, 5, 0, 7, 8. Now there are 3 rows and 2 columns, so the order will be 3 cross 2. And this is nothing but, this is the transpose of matrix A represented by A dash, and this is nothing but matrix A. So, A dash is transpose of A. I hope you are able to understand this. Now then, we are going to move to another important concept, that is symmetric and skew symmetric matrices. The symmetric matrices are those matrices wherein the transpose of A is equal to the matrix A itself. This is the fundamental statement to verify that the matrix is skew or not. And in case it is a skew symmetric matrix, then transpose of A is equivalent to the negative of the matrix A. So, if you see it over here, you can say that A is equal to, given matrix is 1 minus 1, given matrix A is 1 minus 1 minus 1 2. If we take transpose of it, then it will be 1 minus 1 and minus 1 2. This minus 1 turns here, actually this is changed into row, and this is again changed into column. So, you will find that transpose of A is equal to matrix A, is equal to A itself. So, that is why this matrix is symmetric, But so far as the other matrix is concerned, that is matrix B given over here, that is 0 3 minus 3 0. If I take transpose of B, then it will be 0 minus 3 3 and 0. So, you will see that this is nothing but minus of B, because minus of B will be minus of 0 3 minus 3 0, and this will be equal to 0 minus 3 and 3 0. So, this says that B is skew symmetric. I hope you got an idea that what do I mean by symmetric and skew symmetric matrices. Now, there are different operations that are to be conducted onto the matrices. Likewise, we are having the addition operation, multiplication operation, subtraction operation, many more are there. Now, say we are having a matrix A, and we can again use it, say Aij with of order m cross n, and B is again a matrix Bij of order, say R cross S. Then the addition of the matrices is possible if M is equal to R, that is number of rows of both are same, and number of columns of both are same, that is M is equal to R and R is equal to S. So, let Aij M cross N and Bij R cross S be two matrices, then A and B are comparable for addition. They are comparable for addition if M is equal to R and N is equal to S. That is, A and B are comparable for addition if they are having the same order. That is, M cross N should be equal to R cross S, where M is equal to R and N is equal to S. So, by adding the values one by one, we will get a new matrix which is Cij, and the value of Cij will be the respective sum of the values from the matrix A and matrix B. So we can obtain the corresponding elements of by adding the values of a and b, and we will get a plus b is equal to c m or n is a I plus b j m cross n. You will understand this statement when we are going to solve the one of the numericals. Now over here there is an example. Say matrix A is the what is the order 2 rows and 3 columns, and over here 2 rows and 3 columns. So m is equal to m cross n is 2 cross 3, and r cross s is equal to 2 cross 3. So m is equal to r and s is equal to n is equal to s. So you can say that the order of the two matrices are same. So that means the values are comparable. So if they are comparable, the condition of the addition is satisfied. And now we are going to apply the addition part. One by one we are going to add the values 1 plus 0. So 1 plus 0 is the first thing, 3 plus minus 1, 3 plus minus 1, 3 plus minus 1, 0 plus 2, 0 plus 2, 2 plus 0, 2 plus 0, 1 plus 3, 1 plus 3, 5 plus 2, 5 plus 2. So that means point wise we added the values and we got the new matrix, which is 1, 2, 4, 2, 2, 7. So this is matrix Cij and the values are 1, 2, 4, 2, 2, 7. So it must be noted that matrices of different orders cannot be added. It is a very important observation, because say we are having a matrix of this, or this matrix is of order 2 cross 2 and this matrix is of 2 cross 1. So fundamental property that m cross n, if there is matrix A, and r cross s is matrix B, the order, then m should be equal to r and n should be equal to s, which is not satisfied over here. 2 is not equal to 1, so that is why they cannot be added. So there are some more details about the properties of the matrix addition. First and the foremost important property is that the matrix addition is commutative. That means if we add a plus b, then they are equal to b plus a. Similarly, the matrix addition is associative. What do we mean by associative? That if we group the matrices, if we say that A plus B plus C, then it is equivalent to A plus B plus C. Similarly, we are having the concept of the zero matrix. Say if the zero matrix, a matrix wherein all the elements are 0 is added to a matrix A, then it is equivalent to the matrix A itself, because changing the adding the value 0 will not affect the value. So 0 is a null matrix. Fourth point is, say, is if A is an m cross n matrix, then we can find m cross n matrix B such that A plus B is equal to B plus A. That means A plus B is equal to B plus A is equal to 0. This implies B is equal to minus of A, because if we are adding A plus B, then we are adding A plus minus of A, and which is nothing but 0. So that means this is nothing but B is nothing but the additive inverse. B is nothing but the additive inverse of matrix A. So this is if we want to find an additive inverse, then we need to verify the term that A plus B should be equal to B plus A is equal to 0. I hope you got an idea, and it is stated over here also that B is nothing but additive inverse, that is equal to minus of A. Now, the next important operation on the matrices is about the difference. The difference is nothing. If I say A plus B, and then we can is equivalently say A minus B is equal to A plus of minus B. So that means performing subtraction is meaning that we are adding a negative value. So if A I j m cross n and B I j m cross n be two matrices, then difference A minus B of the matrix m cross n will be equal to A plus minus B. Now let's understand this definition with the help of an example. We are having, say, two matrices wherein the values are 4, minus 1, 6, 4, minus 1, 6, 5, 8 and 3, and matrix B wherein the values are 4, minus 5 and minus 3, and we are having 7, 0 and 8. Now point wise if we are going to subtract, then what will happen? 4 minus 2. So 4 minus 2. Likewise, we did it in the addition. 5 minus 7, 5 minus 7. Similarly, minus 1 minus 5. So minus 1. This will be minus 1 minus 5. So this is equal to minus 1 plus 5. So similarly, we can go for the other values also, and 4 minus 2 is 2, 5 minus 7 is minus 2, minus 1 plus 5 is 4, 8 minus 0 is 8, 6 plus 3 is 9, and 3 minus 8 is minus 5. So this is the value of A minus B. I hope you got an idea that how to perform the difference operation in the matrices. Similarly, we are going to understand that one of the important operation, that is the scalar multiplication. Scalar multiplication and vector multiplication are different. Vector multiplication relates to the matrix multiplication, wherein one matrix value is are multiplied with the other values. Where before understanding that, we should understand about the scalar multiplication. The scalar multiplication, the definition of the scalar multiplication says that if A is equal to Aij m cross n be a matrix, and let K be a complex number, then if I then the scalar multiplication Ka of a matrix A and the number K is called the will be equal to K times of A. So that means each and every value of the matrix A, that is equal to Aij, will be multiplied by the scalar constant K, will be multiplied by the scalar constant K. You will better understand this statement when we are going to solve the numerical given below over here. Now say the given matrix A is a matrix of order 3 cross 2. There are 3 rows and 2 columns. Now the scalar constant is 4. So Ka will be equal to 4 times of A. 4 times of A means each and every element of A is to be multiplied by the value 4. So if I multiply 3 by 4, then we will get value 12. 1 by 4, then we will get value 4. 2 multiplied by 4, minus 2 multiplied by 4 is minus 8. 0 multiplied by 4 is 0. 5 multiplied by 4 is 20. 1 multiplied by 4 is 4. So 4 times of A will be nothing but a new matrix whose values are 4 times of the values of the A, minus 8, 0 and 24. If the value is 1 by 3, then Ka will be equal to 1/3 of the value of A, and you will see that uh, this turns out to be 3 divided by 3, that is equal to 1. So similarly, we can solve for other values. We will get 1 by 3, minus 2 by 3, 0, 5 by 3 and 1 by 3. So minus 2 by 3, 5 by 3, 1 by 3 and 1 by 3. So I hope you are able to understand that how the scalar multiplication is going on. Simply we are supposed to multiply each and every value of a matrix with a scalar value. Now let's extend our discussion for the properties of the scalar multiplication. There are two simple properties. Say if k1 and k2 are two scalar values, then k1 plus k2 into A will be equal to k1A plus k2A. It is very simple. Similarly, k1 into k2A will be equal to k1 k2 into A. These are the two important sub properties of property number 1. Apart from this, scalar constant q into sum of two matrices will be equivalent to ka plus kb. So k1 plus k2 of A is equal to k1A plus k2A. Similarly, k1 k2A is equal to k1 into k2A. These are quite simple, so just normal algebraic situations wherein you are going to multiply. Now, the important concept is about the multiplication of two matrices. Say, now we need to understand about the important condition. Say matrix A is Aij m cross n and matrix Bij is matrix R cross S. Now the matrix multiplication is only possible. Say we are having one matrix of order M cross N and other matrix of order R cross S. Then R N should be equal to R. That is, number of columns of the first matrix should be equal to number of rows of the second matrix. Apart from this, the second observation is that the resulting matrix will be of the order M cross S. Or you can say this if it is R cross P, then the resulting order will be of M cross P. So, first of the important observation is when you are performing the matrix multiplication, then the number of columns of first matrix should be equal to number of rows of second matrix, and the order of the resulting matrix will be equal to number of rows of first matrix cross number of columns of the second matrix. So, over here, it is clearly stated that if A I j m cross n and B I j n cross P be the two matrices, their product A B is the matrix C I j whose order is m cross P. So, m cross P such that the value C I j is A11 B I j, AI1 B I j, AI2 B2 j similarly and so on. So, how we get these values? You will understand when we are going to solve in numerical. So, these two are the important condition ki the matrix multiplication is only possible when number of columns of first is equal to number of rows of second. If this condition is not satisfied, then the matrix multiplication is not possible. So, let's understand how to perform the matrix multiplication. So, let's solve a numerical to understand how to perform the multiplication of two matrices. Now, in this numerical, we are given two matrices. Matrix A, the order of matrix A is 2 cross 3. The order of matrix B is 3 cross 2. The first and the foremost important point you need to observe is that number of columns of first matrix should be equal to number of rows of second. Is it true or not? Now, in this case, this is true because first or matrix is of order 2 cross 3 and second matrix is of order 3 cross 2. So, 3 is equal to 3. So, that means matrix multiplication is possible. The second important thing is to observe is that what will be the order of the resulting matrix which we are going to obtain after the multiplication of the matrices. The order of the resulting matrix will be equal to 2 cross 2. And you are going to see over here that the order of the resulting matrix is 2 cross 2. But how we got these values, you need to understand. So, how to perform matrix multiplication? Let's begin with. So, the first thing is we write AB as matrix A and matrix B. Then we need to multiply it pointwise such that the columns of matrix 1 should change and the row value of second matrix should change, and we multiply pointwise. So, first point is 2, 2 into 3. So, you see over here 2 into 3 plus 3 into 2. So, second value is 3 into 2 plus 7 into minus 2. So, 7 into minus 2. So, performing all these operations, we will arrive 2 into 3 is 6, 3 into 2 is 6, 7 into minus 2 is minus 14. So, 6 plus 6 is 12, 12 minus 14 is minus 2. So, this is how we got the first value after multiplication. Similarly, we can do the multiplication for the other values. Just see over here, minus 1 into 3. So, first value is minus 1 into 3 plus 5 into 2. So, 5 into 2 plus 2 into minus 2. So, 2 into minus 2. So 1 into 3 is minus 3, 5 into 2 is 10, 2 into minus 2 is minus 4, and 10 minus 7 is 3. So this is how you got the second value. Similarly, you can calculate for the other values, and you will find that after performing matrix multiplication, you will get a matrix of order 2 cross 2 whose values are minus 2, 64, 3 and 39. I hope you understand how to perform the multiplication of two matrices. Now we understand about the properties of the matrix multiplication. The properties, first of the property is associative property. The associative property says that A into B multiplied by C will be equal to A into multiplied by B into C. So this is associative. We are generating an association. Association of A and B into C will be equal to A into association of B and C. I hope you understand this. And apart from this, we are having a distributive property wherein A into B plus C is actually equal to A into B plus A into C. So we are distributing the multiplication power. So A into B plus A into C. So we are distributing, that's why this is called distributive property. Apart from this, we are having one more property of the scalar multiplication where K into A into B is equal to A into K times of B, and this is nothing but K into A into B. So all are same. This is the third property. And we are also having an matrix, say if identity matrix of order M is multiplied by A, then we can write it like n also, and this is equal to, that means multiplying any matrix with identity matrix as multiplying any number with 1 is equal to number itself. So identity matrix multiplied by that matrix will be giving us the same matrix. This property we are going to use when we are going to understand how to find the inverse of a matrix. So at that point of time, we are going to apply the understanding of this concept, and that's why in the beginning I said that the components of the course are interrelated. This because this is a you can learn it from the self-learning material, which is also being provided as the component for this course. Now let's solve some numericals and verify some of the properties. Now matrix A is given, which is a column matrix, and matrix B is given, which is a row matrix, and we are asked to find A into B and B into A. Now firstly, we check the fundamental requirement. Order of matrix A is 3 cross 1 and order of matrix B is 1 cross 3. So 1 cross 1, where 1 is equal to 1, number of columns of 1 is equal to number of rows of second matrix. So matrix multiplication is possible. The resulting matrix will be of order 3 cross 3. So this is yes, this is the matrix 3 cross 3. So let's do it. So you will find that first element will be equal to 1 into 3, 1 into 3. So 1 into 3. Second will be equal to 2 into 3. So 2 into 3. Third will be equal to minus 1 into 3, minus 1 into 3. Again, second column will be equal to 1 into 5, 2 into 5, 3 minus 1 into 5. So this is how you will get a matrix of order 3 cross 3. So we will get the value AB as a matrix of order 3 cross 3. But we want to see that is BA also of order 3 cross 3. Now order of matrix B is 1 cross 3. Order of matrix A is 3 cross 1. So that means number of columns is equal to number of rows. So that means matrix multiplication is possible, but the resulting matrix will be of order 1, and this is how this is of order 1 cross 1, 1 row and 1 column. So this is an matrix. So BA, so this into this plus this into this, that means 3 into 1 plus 5 into 2 plus minus 2 into 1. So 3 into 1 is 3, 5 into 2 is 10, minus 2 into minus 1 is 2. So 3 plus 2 plus 10, that is 15. So this is matrix of order 1 cross 1. So you can say that AB is not equal to BA. So if you multiply A into B, then 2, likewise in the normal algebra, 2 into 3 is equal to 3 into 2, but this is not possible, this is not true in the case of matrices. In the matrices, AB is not possible to be A. I hope you understand what is the importance of matrix multiplication, how matrix multiplication is performed, and what are the fundamental properties of the matrix multiplication, and we solve the numerical also. Now, uh, these are some of the important observations which had already discussed, but to be on the now we discussed that it is possible that for two, this is one of the most important observation, that it is possible that for two non-zero matrices A and B, the product AB is a zero matrix. The A might not be equal to 0, B might not be equal to 0, but AB might be equal to 0. It might be possible. Two non-zero matrices A and B, the product AB is a zero matrix. Second important observation is that it is possible that for a non-zero matrix A, two unequal matrices B and C, we have AB is equal to AC. That is, AB is equal to AC when A is not equal to 0 must not imply that B is equal to C. That means if AB is equal to AC, this doesn't implies that B is equal to C. This is not correct. So we will check how this is happening. So let's solve a numerical. Now matrix A is 0, 3, 0, 5, matrix B is 5, 3, 0, 0, and matrix C is 6, 7, 0, 0. These three matrices are given. Show that AB is a zero matrix, which was the first observation, and AB is equal to AC. Now we multiply AB, and now AB, so that means 0, 3, 0, 5 and 5, 3, 0, 0. So let's see how matrix multiplication of this into this plus this into this. So 0 into 5 plus 3 into 0 is nothing but 0 plus 0, that is 0. Similar, 0 into 5 plus 5 into 0 is 0 plus 0, that is again 0. Now for second column values, 0 into 3 plus 3 into 0 is again 0 plus 0, that is 0. 0 into 3 plus 5 into 0, that is 0 plus 0, that is again 0. So that means all values are 0. So this is a 0 matrix of order 2 cross 2. So both A and B, A is not equal to 0, B is not equal to 0, but AB is equal to 0, which we had discussed over here. This is the first property which we had discussed. Now we will discuss about the second important property, that is now we calculate AC. Now on the same lines of action, we can say that we find that AC is also equal to 0. We find that AB is also equal to 0, but we can see that B is not equal to C. So if AB is equal to 0, AC is equal to 0, this does not imply that B is equal to C. I hope you understand this. Now let's extend our discussion to some more details, and the important component is exponent of the square matrix. Now the exponent part, say we are having a matrix A and we want to calculate the value of to the power m, and a to the power n will be equal to a to the power m plus n. This is a general rule that when there are the exponent values got added. Apart from this, a to the power m whole into n is nothing but a to the power m into n, where m and n are non-negative integer. Apart from this, any matrix to the raised to the power 0 is nothing but equal to the identity matrix. As we already know that anything raised to power 0 is nothing but n 1. If any number, say x to the power m whole to the power n, then it is equal to x to the power mn. x to the power m, x to the power n is equal to x to the power m plus n. So same algebra rule applies, but many a times the algebra rules are not applicable into the matrices. Likewise, we had seen that AB is not equal to A, is not equal to BA. Okay. So you need to be very cautious when you are using the understanding of the matrices and when you are using the understanding of the normal algebra values. So normal calculations. So this is all about. Now we try to calculate the values of the exponent of a square matrix by solving a numerical. So in this example, we are given a matrix A 2 3 minus 1 2 and function f(x) is equal to x square minus 4x plus 7, and we want to calculate f(a), and thereafter we want to calculate the value of a to the power 5. So f(x) is given to be x square minus 4x plus 7. So what will be fa? Fa will be nothing equal to a square minus 4a plus 7. So this is 7. So that is 7 will be multiplied by the identity matrix. Now in order to find the value of function fa, firstly a square is to be calculated. So a square, that means a multiplied by a. 4 times of a, so 4, there is a scalar multiplication, 4 multiplied by the value of a. Then 7 multiplied by the identity matrix. The identity matrix is a matrix whose diagonal values are 1. Now performing the matrix multiplication for a square, 2 into 2 4, 4 plus minus 3. So that means first value minus 2, minus 1 into 2 is minus 2, 2 into minus 1 is again minus 2. So both are to be added. So minus 2 plus minus 2 is minus 4. So this is 1, this is minus 4. 3 minus 4 minus 1 is 3. So similarly, you can get the values for a square, 4a and 7i2, and you will find that this the result of this is a square, this is 4 into a, this is 7 into I. So you will find that a square turns out to be 1, 12 and minus 4 and 1. Further minus, so this should be 8, 12, minus 4 and 8. So you will get these values. Apart from this, plus 7 plus identity matrix is there. So 7, 7, 0, 0. So if we add the values point wise, 1 plus 8, 1 plus minus 8 plus 7, you will get this value. And after solution, you will find that it turns out to be 0. So function fa turns out to be 0, because by substituting the value, we perform the calculations and you will find this. Thereafter, on the same lines of action, you can calculate a cube. Now, a cube can be written as a square into a. A cube can be written as a square into a. What we are using over here, a to the power m into a to the power n is equal to a to the power m plus n. So 2 plus 1 is equal to 3. So a to the power 2 plus 1 is a to the power 3. So a to the power 3 will be equal to a square into a. A to the power 3 will be a square into a. Now what is a square? We are given the equation. A square minus 4a plus 7. We are given the equation a square minus 4a plus 7, and it turns out to be 0. So that means a square is equal to 4a minus 7i. So a cube will be equal to a square into a, that is 4a minus 7i into a, because a square is equal to 4a plus 7i. So by solving these values, by substituting these value, you will find that by opening the brackets, you will get 4a square minus 7i2 into a, and because I square a, applying multiplying a with identity matrix will give you the result a only. So by performing the solutions one by one, the steps are given over here. You will find that the value of a5 turns out to be this much. So that means you can apply the understanding of the multiplication of the matrices not only to calculate the functions values. Likewise over here we had calculated the value of fa, wherein we were given the function fx is equal to x square minus 4x plus 7. Apart from this, we can calculate the exponential value from the results, as we had discussed over here, that we had calculated the value of a5 also. So students, I think after going through this session, you are able to understand what matrices are, how they are different from the determinants. You understood about the different type of matrices, what are the properties of the matrices. Apart from this, you learned about how to perform the equality operation, matrix multiplication operation, be it scalar or multiplication of two matrices, how to perform addition and subtraction operation, and we learned about solving the numericals. So applying the concepts of the matrices we learned in this session, we solved various numerical problems, and I hope you enjoyed this session. Try to apply the understanding of the content delivered in this session to solve the problems available in the material. Thank you very much.